Hi everyone, good afternoon. I think it's afternoon. So, Georgia, well, just before we get into the slides ready, Georgia are going to be building on some of the great talks this morning on how we've actually used LLMs within to solve a problem within SSRN.
1 second. All yours.
Brilliant. So, let's do it. So there's been a lot of talk about large language models this morning, so I'm not going to go into too much detail, but I guess the way we've been thinking about the large language model and what LLM is really as a sort of AI algorithm that uses deep learning technologies and massively large data sets to sort of understand, summarize, generate, and predict new content, and sort of fitting into that sort of generative AI bucket of content generation. And some of this stuff has already been talked about, so I'm going to just briefly skip through sort of the key capabilities of LLMs in terms of improving searching, sort of more traditional text mining exercises, the whole assisted code development thing, like sort of Microsoft Copilot sort of technologies, chatbot tutors, support bots, things like that, and the summarization of content as well, which is quite interesting for us in the publishing industry. And these things have been around for ages, actually. I know the focus has been, really from last year onwards when we've seen the emergence of things like ChatGPT, Google and Meta in this area as well. But I know our data team at Elsevier, our data science team at Elsevier has been thinking about this problem for quite a while. So it's not a new problem, but it's really, I guess, within the last 12 or so months where companies have really thought about how they can incorporate this technology into their sort of ecosystem. But we should also be wary about the potential problems of applying LLMs into our domains. And some of these have been spoken about earlier as well. Hallucination was talked about. Bias in the data sets, catastrophic forgetting, so things like when you update the data sets is what you previously fed the engine being forgotten and stuff like that. So I think just as we'll be talking about in detail later, as we're thinking about this, we just need to bear in mind about some of the problems that could be happening here as well. So this isn't my slide. This is a slide, actually, I went to a product conference a few weeks ago, Mind the Product. It was a really good slide from someone presenting there, which I wanted to share, and also we're going to be using to think more about the problem we'll be talking about in detail shortly. So this is all about a talk about how to integrate generative AI into your product and some of the sort of steps we should be thinking about when we look into this problem. So I think someone was talking about this earlier on, defining the problem really carefully. So not applying AI just for the sake of it, but really coming up with a clear problem that AI could really help with. So a clear area of efficiency, high impact, ideally a low profile, so not part of a big customer-facing ecosystem, ideally. Data is so key here. You've got to have the right data, large data sets. And if you haven't got the data, before we can even delve into this, you've got to figure out how you're going to get that right data set. So yeah, having the right data is definitely key to moving forward. The whole build versus buy thing, do you have, if you're in a large organization, you may already have a skilled data science team, but in smaller organizations, you may be looking more at off-the-shelf solutions to solve the problem. But also, I guess you've got to think more about data privacy as well when you're thinking about the build versus buy argument. The proof of concept stage is very important, and George will be talking about this shortly as well. So once you've identified the problem, identified you've got the right sort of data set, decided how you're going to solve the problem, POC to see actually, can the AI technology really solve the problem, and get really need to get the sort of, someone was talking about humans in the loop earlier, the subject matter experts involved in this stage. Set really clear success criteria on how you're going to really prove that the problem is being solved before you move on to scaling to production. And actually, when we scale to production, you're still going to keep an eye on the model and look at things like model drift. So LLM changes in a way which could, the LLM may change in a way which could affect its efficiency, because as far as we're concerned, ChatGPT is a bit of a black box. So it may change and it may not be as good in solving the problem going forward. So it's good to keep monitoring it and seeing if we need to actually change LLM technology as well. Very quick slide. So Elsevier is doing a lot of different AI projects. We'll be focusing on one in SSRN shortly, but one of the quite famous ones you may have read about recently is Scopus AI, and this is all about combining generative AI with Scopus content to really provide more detailed summaries, of content, allow researchers to go deeper, do natural language queries, and things like that. And really, this is aimed at two use cases in particular. The use case of a young researcher sort of getting up to speed more quickly in a new area, or even actually more experienced researchers working in other areas, and it's a great way to get up to speed up their learning, collaboration opportunities and stuff as well. I won't talk more about Scopus here, but there's a lot of literature out there for those interested. So our use case is really about, so Georgia and I both work within SSRN division of Elsevier. And SSRN, as many of you may know, is a preprint repository which has been around since 1994, very much focused on social sciences to start with. We were acquired by Elsevier in 2016, so just over 6 years ago, and since then we've moved into all disciplines really, as you can see here, from applied sciences to health sciences, working very closely with the Lancet, Cell, and across the board really. And yeah, just a few other facts about SSRN. We get 2.5 million monthly unique users, paper content and stuff like that on there as well. One of the things that differentiates us from a traditional preprint server is, although we're free to upload and download like any other preprint server, we actually have a commercial element as well. And actually this did exist pre-Elsevier as well, pre the Elsevier acquisition. So there's a variety of value-added services we add that consumers, institutions, hedge funds pay us for as well. I'm not going to talk a bit too much about that now. The key one here, which will fit into the use case example we talk about in a minute, is subscriptions. And this is really where researchers or institutions can subscribe to get updates, and it acts as an early warning system on particular areas they're interested in when there's new content generated in those areas by new authors and things like that. And so the classification of content into a low level in our taxonomy is really important for that product. And that's really the problem we're trying to solve. So it's all about the paper classification problem. So currently, when we get papers coming into SSRN through 3 different channels, our own submission form, editorial manager, and various automators, and they flow into SSRN, and there's sort of 2 levels of classification for a paper. There's a very high level, stage 1, where papers classified at a very high sort of network level. But then lower down, stage 2, is where we really go into granular, and our taxonomy is massive. And this is where every paper is actually looked at by a subject matter expert in a field to really classify it at the lowest level before it can be distributed. So really, it's almost like we think of it as a robot librarian going around trying to find the right place in the library for the content. And this is really the problem we're trying to solve. And I'm going to hand over to Georgia to go into a lot more detail on this.
Great, thank you. Okay, so this is a case study of an internal process. We're working behind the scenes at the moment. As Kunal said, this feeds into a subscription system, so people are getting the papers that get classified this way. So that's when it becomes really customer focused as well, where it's not just internal, it's also external. So at the moment, we have, as Kunal mentioned, we have subject matter experts who literally look at a paper and assign classifications to it before it can get sent out. So as you can imagine, this is quite expensive, takes quite a long time, a backlog builds up, especially in popular areas where there are lots of papers coming through. And also, each subject matter expert works in their particular field. They might do things a certain way, somebody somewhere else does their thing a different way. So we want to try and improve the consistency, and this is what we're trying to use ChatGPT for. So improve the speed, reduce backlog, reduce costs, and improve consistency. So what do we know? We know ChatGPT is really good at classification. From the model earlier we saw of the predictable, disordered, grammatical, etc. It really fits into that predictable grammatical area. So it's really good at stuff like this. We ran an initial trial, which was basically us just plugging things into ChatGPT and seeing what popped out, and it looks pretty good. We know it's flexible. There are other models out there that could do this for us, but this one we can update with a new taxonomy all the time, and it'll pop out great results for us. So this is our initial test. What we did was we gave it a section of our taxonomy, the law network, which is really popular, and then we gave it a paper and said, can you assign somewhere between 2 to 10 labels to this paper? That's on the left, that's the abstract. It's about ethical AI, governance, AI and governance. And on the right is what it popped out. So there are 5 classifications there. That's great, in the right ballpark. And the really exciting thing we thought was cool was that it gave us an explanation as to why it picked those labels. So in terms of black box, not really knowing what's going on, when we think about the future and implementation, we can say, a human can look at this and say, I understand why you've picked these labels, and I can tell you whether you're right or wrong. So that's really cool. So on first glance, it looks great. The only thing about this is 4 of those labels were correct, they fit in our taxonomy, and 1 of them was fake. GPT had made it up. So here immediately on our first test, we can see the problems arising with ChatGPT and what we're going to need to focus on. So just as an overview, it was going through the correct steps. GPT was working well. It can explain its choices, which is great. There were some problems. We had hallucination, maybe an example of catastrophic forgetting, hard to tell. Implementation will be slow because of this. We're going to need to validate every step along the way. We're going to need to get humans to look at all these choices and say, is this right, is this wrong? And we also know right from the outset that we probably won't be able to implement this solution in a blanket way. We have some networks, the medical network, for example, which really needs a lot of oversight. It's really important that we get those papers right and they're validated well. So that we're looking at those to stay on the human side of the classification anyway. So our integration with data science, we're really lucky to have a great data science team, Elsevier, who can help us out with this project. So we're partnering with them. We're going to be creating a solution from things that already exist. So we're going to use ChatGPT. We're going to build on top of that with prompt engineering to make it work for our needs. And on the right here, you can see an example of one of the first prompts we gave ChatGPT to solve this problem for us. So it's pretty long, pretty complicated, and this is just one paper. So this is what we're looking to implement across the board. So what data do we already have about our classification process? So on the left here, this is what our taxonomy looks like in graph form. It's huge. We have 7,800 levels or items on different levels. So we have our 6 buckets. We've got health sciences, applied sciences, humanities, etc. And then when you drill down into those, which is what you can see with the big bars, that's where we have networks, e-journals, and topics. And that's where it starts to get really specific. And we need ChatGPT to sort of comb through all of those different things and find the right classifications. So we know there's a big taxonomy, and this might be quite difficult. On the right, we can see the number of classifications per article that humans are giving on average. So it's somewhere between sort of 2 and 10. That's where the bulk of them are. Sometimes we get up to 40. That's really interesting. Must be a paper across many different disciplines. But most of the time, we're looking in that margin. What is our experiment? What are we doing? On a very basic level, we're going to be giving ChatGPT information about our taxonomy and how we want it to classify. We're then going to give it papers to classify. We're going to compare those papers, the classifications that GPT gave those papers, to human classifications. So the papers we're using have already been classified by humans. They went through our system maybe last year, papers from 2022, and we have human labels and classification labels we can compare. We're giving both sets scores out of 5. We're at a very early stage, so this validation system is quite simple. And then we're going to integrate the feedback we get from those evaluations back into GPT, re-engineer our prompt and try again. One thing we've learned is that because our taxonomy is so big, we can't put it into ChatGPT all in one go. It's just too long. The prompt won't fit. So we're going to have to we've tried to figure out ways to break down the taxonomy into manageable chunks. And this was the first challenge we had to overcome. So we had to find a way for it to search through our large taxonomy and find the right labels. So the first approach we tried was start from the top down. We gave it the 6 buckets, and we said, only look further into these buckets if you think it's applicable for this paper. And so therefore, you kind of only get one tree, and that tree is much more manageable. The second approach is to try and eliminate any classifications we know will be useless for this. So we're trying to classify a law paper. We're pretty sure dentistry isn't going to come into it. So we can try and get rid of those before ChatGPT even looks at it. And this allows for a slightly broader section for GPT to look at and search through to find classifications. So how does ChatGPT think it's doing? So this is a graph. We put 100 papers through ChatGPT, and we got labels. And then we also had the human labels for those papers. And then we asked ChatGPT, which labels do you think are better? And unsurprisingly, it thought its own labels were better. But what's really interesting about this is that it can assess its own labels, and it can already see that it's only 85% correct. So it knows it's making mistakes, and we know that too. So we know that when we're using this system, we really have to validate with humans as much as we can. So how do we think it's doing? Overall, we're encouraged. We think it's a perfect tool for the job, and we're encouraged by the results we've seen so far. This is going to involve a lot of prompt engineering finessing, so we're having to talk to it a lot, update the prompt a lot. But as we're doing that, we're confident that the progress it's making will match that of an average human. So we think the classification process will work here. And we're also seeing rapid progress. We can do this very quickly. We can start a new round pretty much whenever we want. We can see the papers, we can classify them, and we can integrate feedback. Here are some challenges we've had to overcome along the way. So the first challenge is that GPT was breaking our classification rules. We have some things that we don't do, the humans don't do. We don't pick too many topics from the same area. We like to keep that smaller, and it didn't know that, so we had to teach it that. It's just an example of things that you might not think of that GPT has to know. Sometimes it wasn't assigning any classifications. So it has a standard for how well it thinks this classification applies to this paper, and if it doesn't meet that, it just won't assign it. So sometimes we just got no classifications, which obviously is not ideal. And also sometimes it made up its own. To address that, we just had to ease the standards. We had to say, okay, if you can't find any within this bracket, try the next one. You know, if it's not 90% correct, try 80% correct and see what you come up with. Sometimes it's selecting into journals that we don't use that often. For example, negative results. This is quite a specific kind of journal, like only some papers really belong in there. And it was sometimes reading the abstract and finding, negative words. It would say, this does not affect this. And it would say, that must be negative. And it was putting in those journals, which was not correct. So we had to, for the moment, we've excluded those journals from our experiment just to find out how the main thing works. And then we'll start to work on those later. This is quite interesting. So in terms of bias, sometimes when you're programming these kind of things, you can add bias you didn't really know was there. What we're actually trying to do is add bias. So we have some networks like Law, which are really popular. Lots of people subscribe to them. Lots of papers go into them. We're really keen to get papers into those topics if we can. So we're trying to say to GPT, if it's relevant, obviously don't do it if it's not, but if it's relevant, please add a Law classification to this. So we're trying to embed bias, which is a slightly tricky thing to track because how do you know you've done enough or done too little or etc. So we're looking at that. And then lastly, sometimes it just wasn't finding the right classification. So it would get rid of a bucket, would get rid of humanities. And actually, deep within humanities, there is a topic that would have been really good for this paper that it didn't know was there. So this is how we came up with our second method, where we try and get rid of all the ones that are completely unnecessary so that it has more space to look through other ones which might be. So how can we begin to implement this? Right now, we're in the ideation phase, which is basically we're just trying to figure out how this thing works. And we've set our acceptance criteria. We know what we want, the level we want GPT to be performing at before we can continue. We're adding to the prompts. We're constantly re-engineering, finessing, etc. And we're using a comparison tool. So we've got this nifty software which will really easily let us compare human labels, GPT labels, and collect all the data to analyze later. Further down the line, how do we implement it into our classification process? That's definitely a dev question. But what we're thinking overall is that we'll start with the lower risk networks, things like agricultural science, for example, which are less popular on SSRN. We'll start there, make sure that works before progressing, hopefully, to the bigger networks like law, economics, finance, to see how it works there. So what does this mean for SSRN? How will classification look going forward? Hopefully, it'll be much more automated than it is, much simpler, much more consistent. But we're also thinking about our classifiers. So we have subject matter experts who work in this field right now, and they are classifying papers manually. We are really thinking about that human-in-the-loop model, which we heard about earlier, where we need humans to be looking at these classifications. We can't just assume it's right. So we're really thinking about implementing a system where, I don't know if you've ever seen a chatbot on a website where you get feedback. You give it feedback. It says, how was your interaction today? And you say, good, bad. That's the kind of thing we're looking at. We're going to say, these classifications, how well have they classified this paper? And then a human will input some data, it'll feedback, and we'll learn more. So the role of a classifier will change. It'll be more about validating GPT and the work that GPT is doing. Going back to our 5-step model we looked at earlier. So at SSRN, we've defined the problem. We have an expensive, slow system for classifying papers. We want to improve that. We've evaluated our data. We've looked at how our classification process works now and how GPT needs to emulate it. We've looked at build versus buy. We decided the model out there works for us, and we're just going to build on top of it. We're in our proof of concept stage, where we're making sure the level of classification is good enough for us to be able to implement it into our system. This is overseen by our director of content classification. She's setting that acceptance criteria, and then we're going to be seeing how it's performing. Further on, we're going to scale to production. We're going to implement this into our system and hopefully get GPT to classify our papers for us. And now I'm going to hand back over to Kunal to talk about some things we've learned.
Thanks, Georgia. So very quickly, just going to summarise with some of the lessons we've learned on this journey. Prompt engineering is really tricky. So as Georgia reflected, there was a number of places where a taxonomy was very big, so it couldn't, analyse it in one go, so we had to sort of split that up. It was breaking our classification rules and all that sort of aspect. So it's very tricky. We need to spend time thinking about exactly how we're going to simplify what we're asking the AI to do. And in this case, where we asked it to look at one level of our taxonomy at a time was one solution. Working with AI is a data science problem, and Georgia and I are both product managers. We're not that fluent in this area, but we've got data science experts we can call on and a team to really help us along this journey and become part of that team for this work. Validation is key, and testing. We've reached our success criteria. It can be time consuming between number of stakeholders there. You've got the data science team, you've got our subject matter experts, classification teams. So there's a lot of iterations happening, and this stuff is probably happening alongside people doing other roles as well. So it can be time consuming, so you've got to factor all this in. And then finally, there are costs with using an LLM, and we've had a look at these for the ChatGPT bot we're using. But these are actually lower than our current classification costs of humans looking at every paper. So there will be some reduction in cost by using this model, but also, as Georgia mentioned, we still need some aspect of those classifiers to be checking this and constantly looking at things like model drift and checking how well the model works once it's in production. So that was our talk. Very happy to answer any questions.
Thank you. About the last point on your slide, the costs, and I'm aware that you probably can't answer this right now, but the thing I'm worried about is OpenAI currently operates at a huge loss, if I'm not mistaken, and I would also assume that energy costs are probably not going down over the next couple of years. So do you see a risk there that once you're locked into that pipeline and into that technology stack, that at some point they might turn on the screw and just...
It's a really interesting point. So at the moment, our data science team is looking at the top GPT-4 model, actually the most expensive one. And I think as we iterate, we're actually going to look at, if we move to cheaper models, how does that affect our efficiency and things like that? So that's very much being looked at. But yes, we don't know what's going to happen in the future. I don't know if you've got anything to add to that.
Yeah, I think also I'd just say as well that, machine versus human is just a lot cheaper. So to be honest, even if GPT does become more expensive, we're still looking at probably quite a significant reduction. It's definitely worth it.
Yeah, I can't go into the numbers, but our classification costs are huge if you look at them. And even if the GPT costs were to double or triple, it would still be marginally, yeah.
Thank you for your presentation. I have the two questions. So first one, we also have to try the similar things, using the ChatGPT and Googlebot to tag the content, classified content. But we found that the one problem, as you just mentioned, is a hallucination. So they create the fake, the topics which doesn't belong to the taxonomy. So with your solutions, have you managed to get rid of all the the hallucinations, all the fake topics at all, or is still something exist?
Yeah, we've had mixed results. Sometimes it works quite well, and sometimes it doesn't. To be honest, the best way we've seen is just to keep reminding it that it needs to use our taxonomy. It sounds silly, but that's the main problem. Is it just forgets or ignores that we have a taxonomy there for it to use. So our data science engineer is working on that. It does crop up, but I think he's confident that he can make it work.
So how do you make it work? So for each classification result, you have to match each topics to the taxonomy. If not exist, you just remove it?
Yeah,
okay.
Pretty much.
And thank you. Second question: have you tried to compare with the ChatGPT version with dedicated classification AI models? Because before the ChatGPT, we always build our own the dedicated AI models for the specific taxonomy, and then this is more focused, more specific. So have you tried to compare not only between the human and ChatGPT, but also human and the dedicated AI model and ChatGPT?
The short answer is no, we haven't. We're in the first testing of the GPT model, and we're trying to get that to pop out classifications that are solid on a consistent basis. So that's our first step. I think later down the line, that is an interesting question about whether other AI models might work better. As I mentioned, we did try a more fixed machine learning approach to this, and we found A, it didn't work very well, and B, we are changing our taxonomy quite frequently, so we want something a bit more flexible. So we'll see how ChatGPT goes, and then we'll continue to look at it from there.
Okay, thank you.
Hi, so thank you for the presentation. Going back to hallucinations,
Sorry,
going back to hallucinations, so is it wrong, or actually it's right, but it's not part of your hallucinations that you're considering changing your taxonomy?
Yeah, so a mix. Sometimes it's fully wrong and it makes up the classification. Not too often, but other times it picks the wrong ones. And that's really where the prompt engineering comes into play. That's really what the main focus of the experiment is to say, these topics aren't wrong. They might be slightly less relevant than we'd hope. It's missed the ones we really wanted it to get. So that's why it requires so many iterations, because it needs to search through so many different levels, so many different labels to find the right ones. And that's really what we're aiming for, is that it selects the most relevant classifications most of the time.
But you'll use it to update your classification? Are you going to use it to update your classification, saying that actually they're better than our classification? Is that something that you're considering?
Sorry, I didn't quite catch that.
Sorry, updating your classification. So actually what the terms that they are coming up is actually better than your current classification.
Yeah, that's one of the metrics we're using. I think at the moment we're aiming for the same level. So if it can do as well as a human can of the classifications that already exist, that would be the first step. Hopefully we assume that, we hope that it will end up being better, but that's a future.
Sorry, and another question about the people involved. Because there's a big impact in your team if people are doing the classification. What's the human impact on this project on the company, to be honest?
Yeah, I can talk about this briefly. So we've got a dedicated content classification team, and we've got a number of teams that do content classification. This is the team that do the lowest level. So it's generally who they are as subject matter experts, and they're generally doing this as part of their role. They're generally either outside doing professors, researchers, doing other stuff. So this is sort of a thing they do almost in their spare time, to be honest. At the moment, we're very early stages, so we're not thinking, because we don't even know if this is going to work. Be it successful if we could replace them. But I think the longer-term initiative is still to, as we mentioned, still to have some kind of team there to be doing the checking. It's just how big is that team in the future? We do anticipate it will be smaller than the current team because we're automating a lot of it.
And what's cool about this as well right now is actually it doesn't involve too much resource. So we have our data scientist who's building the prompts, and we have our director of content classification who's validating those results. And that's kind of working on its own. We don't have to get involved with classification just yet. So it can work kind of separately to our whole system. And then we can only start to integrate it when we think it's at the right level.
Hi, I've got a question. Thanks very much for your presentation. It's really interesting. It's really interesting, especially to hear about the specific steps that you've taken in the process and the problems you've been trying to solve. I just had a question about research coming from researchers who are operating in a multidisciplinary or interdisciplinary way, and what that means in terms of classifying, because that's often a problem for kind of where they want to put their work anyway. Do you see GPT to be a tool you can reach to, or do you potentially see it as something that might perpetuate some of those issues?
So that's a really interesting concept. Because a lot of our really interesting question. Because a lot of our content on SSRN is multidisciplinary, and actually one of the big issues with the current classification process is if you have multidisciplinary content, it actually is getting not one subject matter expert looking at it. It's going to be maybe 4 or 5 that's being passed around. And one thing our content director has always said since he joined us a few years ago was, we almost want a one-touch model where each paper's only been looking at once. But it makes it tricky when you've got particular experts in different areas. So hopefully this problem means, it doesn't, it can happen in sort of one step rather than having to go around different specialists. But I don't think we've got anything to add.
Yeah, and as with that, there's always a ranking. This paper applies more in this area than it does in that area. So we're really keen to get those first rankings right so that it pops up in the really relevant areas. As you saw, sometimes we have classifications up to 40 on a paper. So sometimes it really can be a whole big step process. And I think the key point here is as long as GPT knows those classifications are there, as long as it can search in the right areas of the taxonomy, we probably shouldn't have a problem. It should be able to select the ones that apply the most. But yeah, just getting that visibility is the most important thing.
Great, thank you.
Hello. So did you have any security concerns with the data that you were uploading? And if you, I mean, I'm assuming you did, what steps did you take to take care of that?
Well, interestingly, we're feeding GPT our taxonomy. That's freely available. You know, you can go onto our browse page on SSRN and look at the taxonomy, and you could download it. You know, so
yeah. And similarly,
yeah,
you know, we're using the papers that we feed in. We're feeding in the abstracts, keywords, titles, etc. All of which again is freely available on our website. The classifications that pop out, similarly, we're not super worried about those. I think probably at a higher technical level than I'm capable of, there are some data concerns. But for now, for this experiment we're running, most of the stuff is pretty good to go.
Yeah, and there's loads of our legal team are heavily involved in all of this as well. So that's happening to the side, you know, as well, to think about the legal implications and things like that.
Thank you.
Yeah, just a quick follow on from that. Could you dive into the sort of the legal advice you received, obviously within limits of confidentiality, a little bit more? Because, you know, there's the subtleties of if your papers are under, let's say, a CC BY or similar attribution license, how does that play into things? Or are the terms of your taxonomy reusable? You know, they may be freely browsable, but is it freely reusable? My experience of Elsevier's website, like most publishers, is that the answer is, well, once you're making money out of it, no, we'd like to sort of have a conversation, please, which is a fair thing for any publisher to want to bring up. So could you sort of pull apart that a bit more if you have any?
Yeah, it's an interesting one. Yes, generally, because we're sort of, it's a bit different with SSRN just because there's no sort of paywall or anything. So generally, it's okay. But,
And I think we have conversations about copyright a lot and things like that. And because these papers aren't published, they're preprints, so authors upload them literally like you would on a blog website. So we don't have too much issue with copyright because these papers haven't been published. So the author signs it over to us and says, yeah, I'm happy for you to post this on your site and to do what you want with it. So for now, we haven't run into any problems. We do have legal oversight on this, so if there are problems, I'm sure they will be.
I'm sure that issue will come up as we go further down the pipeline. But yeah, as Georgia was saying, when an author uploads, they sort of sign our TNCs and they sort of, with those sort of terms.
Thank you.
Brilliant. Thanks, everyone. Thank you.
Thanks very much.